Hello everyone. Today we are going to discuss about the five methods. So we will implement in our array list index of, last index of, size or get size, is empty and contains. And this is our last video for the our array list implementation from the coding interview perspective. And because after that there are many other methods for the coding interview. I think that is enough, and then after this we will start the linked list implementation in a JDK. Yep, we will discuss later that. Okay, so again, first we will review the code together on an IDE, and then we will come back and discuss some use cases.
So indexOf method, the definition, basically the expectation from this method is if we find this object in our array list, we should return that object's index, otherwise -1. So what they are doing basically, first again they are checking null. If it's null, they are taking care of that separately, and I think it look like more maintainable if we divide our branches null and not null. Otherwise we can do in only in inside of if the for loop, and then we have a if check if it's not null, but it look kind of ugly and it look pretty nice. Yeah, there are more lines of code, but it still look pretty nice. So we can read this now. So if it's null, then there is a loop and it's checking each and every index. It means it's going to be big O of n. And the same for the else case. Again, they're doing the same thing. So it's a big O of n. And if you remember, we have same kind of implementation for case of a remove. So they are doing the same thing. They are checking. Once they are done, they are calling the fast remove. And same if it's not null, they are again calling the fast remove, and then they are returning true and false. Then the next method is last index of. So in this case, the difference is only the start of the loop. So they start from the end and they are going until 0. If they found, they will return. So basically both methods are giving us a guarantee they will send you the first occurrence of that object. Then mm, size. So in case of a size, as you guys remember, we already have our size of integer, and we are updating when we do add. If you remember in our add method implementation, where we have this add, this one. So every time we are taking care of size on our own. So size plus plus, and when we do remove, we are also taking care of size minus minus. So we are sending that size directly. So it's a big O of 1. It's only a method call and we are returning that, which is good. Then the is empty, again it's a big O of 1. Every time we will see if size is equal to 0, we are returning. And this method is, so here we can learn two things. One, the reusability of methods, which most of the time I felt we most of the developers don't care about the reusability of small methods. They always try to implement, okay, but in this case you can see it's a pretty good use of index of. So they are saying, okay, index of O, and if I get greater than or equal to 0, we will return true. So which means I'm saying yes, this object contains inside of that. And if I have a -1, then what will happen? -1 is greater than equal to 0. No, so it's false. So now you can see it's a big O of an operation. But from the client perspective, if you are going to use contains, I will strongly recommend you to use index of directly, because sometimes what happen, you use contains. If yes, then you are again doing the some logic by using maybe index of, you are trying to figure it out. So in that case you are doing big O of n verb twice. So that is good if you directly use index of. and then you see if it's -1, it means that does not contains. Otherwise, do what do you want with that index. So you are still, it's your work is big O of n, because you are doing outside. It's kind of a 2n, so it's pretty good by using directly this, and that is the benefit by reading the implementation of the JDK. So for today, we discuss 5 methods, and they're pretty straightforward. Index of big O of n, last index of big O of n, size is empty a big O of 1, and then contains is a big O of n, because under the hood it's using index of method, which is already big O of n.
So welcome back. First, we will discuss the indexOf method. Just like you guys already saw in a code review, indexOf is a method which is a big O of n. So if we use this indexOf, and if I say 3, I will get the answer will be 0, 1. So 1 is the returning value because we have a for loop. And now if I ask 4, then I will get 0, 1, 2, 3, 4, 5. So my return is 5. Now if I ask maybe, which is not available, is 10 or maybe -1, in that case it will go until end of the size of the array, our element data, and then it will return -1. So when we are saying okay big O of n, what does that n means? N means size of the element data, and big O means worst case. So in worst case we need to scan until end of size. So here you need to completely convey your message. Here n means size of the element data array. Okay, then in case of last index of, so basically in this case from the name it look like I will start scanning all from start, and I will check okay I figure it out. I will save the frequency of that method, the index. Okay, I got these 3 on 1, then I will go okay I also got 3 on maybe this index, so I will update that. So from the implementation perspective, like in code review we already know we started from the size and coming back, and at a first attempt we are returning this. But if you got a question like an interview, something around that, so always try to think okay if you are going, because the information which is asked you is like last index of. So most of the time what we think okay last index of, it means I will start from 0 and I will save that information where I will get the first time. So maybe I have some kind of a variable, and then I will say there okay index 0, 1, I will say 1, then is again okay I have a 3, so say 3. But from the implementation perspective, don't only focus on what is asked. Try to understand when you are going to give the information, the instruction to the computer, how you can play with that. And that is the best use case where we can see the ask is last index of, but the implementation is basically I'm checking again the first from the right side. So in this case I will get 0, 1, 2, 3, 4, so it will return me 4. Then anything in this method, there are many things same. So again it's again a big O of n, but what is n here is the size of the element data. Again not the capacity, the size of the element data, how many elements we have. Then size, if I'm calling okay get size, this is pretty simple, like we are already saving that information in a size variable. So just like we will return what is the information we have inside of that, so it's always big O of 1. In case of a isEmpty, so again you remember we are reusing our size. So if size is equal to 0, then it means it's true, otherwise it's false. So here we can see the reusability of the internal implementation. Now in case of a contains, three. So in this case, we will go to the indexOf method. IndexOf method will start. IndexOf say, okay, I have at 0 1 1. It will check 1 is greater than equal to 0. Yes, so it will return true. So again, it's a big O of n operation, but here we can see the good reuse of the method of indexOf. And from the coding perspective, most of the time in your daily job, sometimes I used to write also that like this. Okay, if something like I have my array name, maybe anything, maybe array dot contains 4, then come and then do something like, okay, array dot index of 4 and play with that. So in this case, now you can see this operation big O of n, then again this operation big O of n. So here we are doing basically as a whole it's still n, and we can say it's 2n, but if the from the perspective of the performance or efficiency of your code, it's bad. Like, why you need to do twice the same thing? And I can change easily this by doing, okay, maybe value array dot index of 4. If value is greater than equal to 0, do what do you want. So in this case we are only calling once, so there is only n, and this is a one operation, we go one constant operation and do. So here you can save like too many cycles of the CPU. Now the question is it readability? There is a question some can ask, like, why you are not using contains, because there is a readability issue, I can see. So here maybe you can resolve that conflict by throwing this, or maybe you can go with that if you know n is always less than 100 or 500. That is okay in these days. So yep, so this is our last lecture on the OurArrayList, and now we will move towards linked list. Bye.